Hello, everyone. Welcome to this workshop. People are still coming in, so we'll just wait a few minutes to let everybody to join the room. So yeah, in the meantime, if you want to open up your chat window, there's a conversation going on. See, there's a lot of people from all over the place. We've got someone from Germany, someone from Israel, someone from Switzerland. And let me switch this back. Perfect. Right, so welcome to those who just joined. More people are coming in. Hi, everyone. There it is. Wow, a lot of people are coming in. Whew, that's great. Looks like we're gonna have a big crowd today. Out of curiosity, in the chat window, if you want to tell me where you are, because I find it amazing to have those virtual events where instead of having just a small geographically, a small group of people all located at the same place, we have this wide range of audience, people coming from all over the world. That's great. Also, I'm curious, people from Germany, from New Jersey, United States, Stockholm, Sweden. Nice. I was actually in Sweden last year at this time of the year. Slovenia, Switzerland, Toronto, Canada. Yay. Hey, look at that. Romania, Slovenia, India. Wow. Indiana. That's great. I say it's amazing to have people from all over the place. Okay, we'll just wait another 2 minutes to see if people are coming in, and then we'll get started. All right, let's try something out. I saw recently that Zoom has this feature where like there's a little button that says yes, no, go slower, go faster, more. I'm curious if everybody can see it and how it can actually work. I just want to see the results. So can anyone see those buttons? If you can see them, click on yes. I want to, oh, there it is. There's a count. Well, there's at least 2 people paying attention. I don't know if you all can see the numbers as well, but that can be, oh, slower. Okay, I'll go slower. Faster? Juan, yes, we will be recording the workshop. I will start the recording, actually. That's a good reminder for me to actually start it. If I can just find that record button. Okay, so let's record this. Just a warning for everyone. So we will be recording. If you are not okay with recording, well, you can still jump out of the meeting if you want. It will be recorded. I believe it will be shared at the end. Just a quick note, there's a Joel Lord right there, but I'm actually in the NodeConf remote tab. So this is the one tab that you'll want to pin into your Zoom meeting so that you can actually see everything. We'll be spending a lot of time in the console. I think my text is big enough. We just tested it a few minutes ago. Hopefully that will do the job for now. We'll see. We'll see how that goes. It seems like those buttons are working. So the Zoom buttons there. Let's see if I can clear them. Clear all. All right, that doesn't seem to work. Okay. Well, I wanted to use those. Anyways, so I have the chat window right here that I can monitor. So that's why you'll see me looking at my screen from time to time. So if you have any questions at any given time, we can stop or I can pause. I can answer questions. I'll try to help people as we move forward so that everybody kind of is able to do all the steps that we want to do today. But if I can't answer those questions, I will definitely share my GitHub repo so you can actually copy and paste some of the snippets that we will be sharing. And then I'm happy to answer any questions after this presentation. So it's 9:05 or close to 9:05. So why don't I get started? And I already said that I'm going to spend a lot of time in the terminal. So I'll just get into my terminal right away. I'll just move away. There it is. Okay, and from here, I will start my slides. NodeConf, JSON. There it goes. So hands-on intro to Kubernetes, specifically for JavaScript developers. So I'm going to focus a little bit on JavaScript right here. Mainly, my focus will be on Kubernetes. So it doesn't really matter what language you're working with, but I'll try to keep a focus on JavaScript. So there you go. So if you want to follow along for the examples, so the first thing, I'll be using Minikube. So Minikube is a way to have essentially a mini Kubernetes cluster running on your laptop. I think it's a great way to actually get an intro to Kubernetes. You can actually test it out, try different things. Great way to play with Kubernetes. There's also this one. So if you don't want to install anything, or if you are running out of time, you can also use the Katacoda right here. So this will give you a Kubernetes cluster that you can use for about an hour. We will have some issues when we come to ingresses, which is a way to expose our cluster to the outside world. I don't think they work as well with Katacoda, but you should still be able to follow along, do most of the steps that we will see today. Now, this presentation is recorded, so you'll be able to watch it afterwards. I will share my slides afterwards, and you will also have access to my GitHub repo. So what I definitely recommend is trying to run Minikube, install that on your machine. If not today, you can definitely install it afterwards, and then you'll be able to run all the examples that we've seen today at your own pace and really explore a little bit more. We've got a lot of content today, so I'll try to go through it, and so that we have the time to do everything. I have at the end a little bit more advanced concepts that I wanted to show. Hopefully, we'll get we'll be able to get there. If not, that's fine. You'll still get a lot and more than enough. All right, brew install Minikube. So go ahead, install Minikube. I also forgot, I just remembered that you'll also need kubectl, and it's not part of Minikube. So kubectl install is, there it is. Let me just give you the link for the English version. All right, I'll post this in Zoom. So you can also, so if you're using Minikube, you also need kubectl, which is the command line tool that we will use. Okay, so why don't I get started with this workshop? As you're installing, I'll talk a little bit. So first of all, let me introduce myself. Hi, my name is Joel. I work as a developer advocate for Red Hat OpenShift. So OpenShift is a Kubernetes distribution by Red Hat. So if you're interested to learn more, feel free to reach out to me afterwards. I am based in Ottawa, Canada. So yay, Canada. I saw that Andre is also from Canada here. That's nice. Represent. I love Twitter. So if you ever have any questions, if you want to reach out to me for any reason after this workshop, feel free to note this. So Joel__Lord is usually the best way to reach out to me. I am a big fan of Twitter, so I'm always looking at it. My DMs are open, so feel free to send me a direct message or just a public tweet to say how much you appreciate this workshop and so on, so that it helps me to with my bosses. So, all right, so we'll be talking about that. So Joel__Lord, if you want to reach out. Let's talk about a little brief history of. Well, just before I actually jump into that, let me talk a little bit more about myself, because I love to talk about myself. But seriously, though, I joined Red Hat about a year and a half ago now. And I didn't know what Kubernetes was when I joined. And I joined as a developer advocate. So my job is to talk about Kubernetes and explain what it does. So it was quite a steep learning curve for me. So, and I come from a JavaScript world. So I've been doing JavaScript development for over 10 years now. And when I started with Kubernetes, I didn't even know what a container was. So I had to kind of learn what a container is and then learn about Kubernetes, which is an orchestration platform to manage your containers. So basically a way to deploy all of your containers. So there was a lot of things to learn, and this is what I wanted to show you today. So I want to give you that little 90 minutes walkthrough of what is Kubernetes, so that you have a sense of it. There's a lot of things I'll try to show you how it is and how you can use it with Node.js specifically. I'll talk a little bit on, I have a Vue.js application that we'll try to deploy today. So you'll get a sense of how that works. But really, I want to focus on Kubernetes and how you can deploy those containers. Now, out of curiosity, let's see if I can clear those again. No, why can't I? Just in the chat, who here works with containers on a day-to-day basis? I just want to get a sense of our crowd today. And everybody went quiet. All right, so I'll assume some people might be. Just so that everybody's on the same page, I'll start by talking a little bit about containers, what they are, just so that I make sure we're sure that everybody is on the same page. All the cool kids are doing it at my job, not me though. That is exactly how I feel most of the time with containers. Now, more and more, I can see the value in it, and I'm starting to use them more and more. But yeah, that's kind of how I felt. I was like, yeah, everybody seems to be using it, but I don't see any value in it. Why should I even be bothered with that? Kim is saying we run Kubernetes in production today, but I have not touched it. Much for trying to learn more. Okay, cool. Okay, so just so that everybody's on the same page, let's start with a brief history of container. Not history, actually. I'm a big fan of Stephen Hawking, so that's why I use that. So what is a container? Container is a lightweight standalone executable package of software that includes everything needed to run an application. So that includes your code, runtime, system tools, system libraries, settings. So really, how you can see a container is basically one giant, big executable zip file that you can then take and put that on multiple environments. So because it includes not only your source code, but also all the runtimes that are required to run it, it makes it very, very portable. So it makes it easy to bring that to another environment and to reuse it everywhere. So that means that your working environment or your development environment, if you're using a container-based environment on your local machine, will be the exact same one as the one that you have in production. So that reduces the number of errors. You can also take that same environment and share that with your Q&A team. So that reduces a lot of the frictions that you might have when somebody finds a bug and it's, you can't reproduce it on your environment. I'm sure a lot of us ran into that. So that's kind of how you can see what a container is. A good example, one of the first use cases that I had was one of my friends came to me and needed help with a PHP project. And I used to do PHP back in the days, but now I don't even have PHP installed on my machine, right? But I was able to spin up a container very, very easily. And it came with an Apache server pre-configured with PHP. And I was able to immediately put the code in. And I was able to start running all of that code. So it made it very, very easy. And then I had that environment that was exactly the same as he did. So it made it very easy to help him out without having to do all of that installation and trying to configure all of my Apache server. I don't know if you did it. I haven't done it in a few years, but it was a nightmare trying to run that on a Mac. And then you've got all that stuff that you want to delete afterwards. And it's just, there's no way to remove it. All right, so we've got people sharing gifts. Now I'm curious. Let's see. Let's share this with the team, with everyone. So hopefully it's safe for work. It works on my machine, then we'll ship your machine. And that is how Docker was born. That's pretty much, that's a very good analogy. So basically, it really helps you to be able to share that environment so you don't have to ship your laptop to your customers. So to start a container, you'll have something like that. So we'll be using a lot of command line. We'll spend a lot of time in our terminal today. So Docker run is the way to start a container. In this case, I'm running a container in detached mode, so running it in the background. I'll always use a --rm flag. That's a pro tip there. When you're using containers, it takes up a lot of disk space because you've got all of those big, as I said, kind of those big zip files that are cached on your laptop or on your hard drive. So it takes up a lot of space. So by using --rm, it makes sure that it cleans up everything afterwards. You can give it a name. So if you start scripting if you want to automate some stuff with your containers, you can give them a name, so it's a lot easier. So I have a small script that I have set up on my machine where I just type start nginx, and it starts a a container running Nginx, serving files from the folder in which I am. So that's very useful if I want to test out. If I have a static website that I want to test out, my blog site, or my blog, for example. I want to just update a page. Then I can start that server running, serve local files. Then I can just use localhost 8080 and I can see the result. When I'm done, I just type in stop nginx and everything is using named containers. So it makes it a lot easier to be able to manage that. If you don't give it a name, it'll have a random name. So those are a little trickier if you want to automate some stuff. Cool. You can do stuff like mounting a volume. So I can say, well, take the PWD as the current working folder on my machine and mount that into the /app folder inside my container. So as far as my container is concerned, the /app folder will have the files from my local file system. So I'm really mounting that and faking that the /app folder is not a real folder inside my container anymore. It's really my local file system that is there. So that is very useful. Once again, if you want to mount or start an Apache server, then you can mount a local file system into /var/ww/html, and then you can serve the files from your local file system. You can also mount some or map some ports. So in this case, I'm saying, well, the port 3000 on my local machine will map to the port 3000 in our container. That works well if you're using, once again, if you're using Nginx. Nginx will run on port 80 by default, but you cannot serve anything from port 80 on your local machine. So you'll want to map a port, something like 8080 on your local host. That will map to port 80 inside that container. So now if you do that port mapping, you'll be able to use localhost 8080, and that will map inside your container to the port 80. Then you can specify a base image. So containers are all about base images. So basically, you always start from an image. In this case, I'm starting from an image called Node 14. There are many, many different images that are available. Let me pull up my browser once again. Where is it? There it is. You can go to hub.docker.com and you'll see a lot of different images. So if you want to start a Node.js project and containerize that, you'll find official images. Always look for official images if you can, or else somebody will end up mining Bitcoins on your laptop. and you find here all the different versions. So if you want to test out the latest version of Node 15, for example, well, there it is. You can start a container. You're running Node 15. I was using Node 14 in my demo. That's what I'll be using today. And there's a lot of information on how to use those containers. So start with a base image. So if you want to run I'll use PHP and JavaScript examples, but if you want to run PHP, there's a PHP 7.4 image that you can use and start using PHP right away with your container. And finally, you specify what is the command that you want to be executed inside that container once the container is started. So in this case, I'm using node/app, which will start my index.js file in the /app folder, which was mapped from my file system right here. You can also build Docker files, which will be a way for you to create your own big zip file. So in this case, we've used a pre-built base image. So we've used Node 14, but I could also package my own image so that I would not only have a Node 14 in there, but I would also have all of my source code. So you can start from a base image. You will expose the different ports that you need to change your working directory. I can copy files from my local file system into that container, then run different commands to set up your machine. So run npm install in this case, and that will download half of the internet, basically, install all of that into the Node modules inside that container, not on your machine. So all inside that container. And that's it. You have that big container, that big zip file that is ready to be shipped. And finally, you use cmd to say when a user uses docker run, this is the command that you will start. So npm start will actually start the Node.js server or whatever it is that you have running there. I see that people are joining in the waiting room. So let me just see, make sure that I accept everyone. There it is. Okay, so good. So this is kind of how it works. Once you have your Docker file, you can use Docker build, which will kind of compile that into an image that can then be used. And then you push that into a shared registry, and then you can use Docker run. So in this case, I will actually be using an example of that hands-on Kubernetes say hello. Let me actually open it up right here. It's not right there. Where is it? Not there. I need to find my files. Let me just find it. All right, there's another VS Code window. There it is. Okay, so in here, I will be giving you examples on Node. We'll have an image. We have a tiny application called Say Hello right here. So that's it's all JavaScript, Node.js, and it just logs some stuff. So every 15 seconds, it logs hello world from the host name, and it will also add a timestamp to it. So that's all it does. So it's just every 15 seconds it outputs that. I built a Docker file for it. So from node 14, changing my working directory, copying the files, running npm install. Not that there's anything to install, but still. And then I just run a command node dot, and that will start our index.js. So I did the, where's my slide deck? So I did Docker build, so that built my container, and then I did a Docker push so that it's now available on Docker Hub. And then you can use Docker run /hands-on Kubernetes say hello, and that will actually run that container inside your on your local machine. All right, let's see if we have anything in the chat. All good, perfect. All right, if you want to learn more about containers, because that's really not the topic, but I know that a lot of containers are getting more and more traction, but especially with large enterprise developers, and a lot of JavaScript developers are not on the, haven't started using them yet. So if you want to find out more, easyurl2/containers. There's a talk that I give on containers, or you can search on YouTube for containerization for software developers. You'll be able to find a recording there. There's a few links to help you. There's a link for a cheat sheet that describes all the different commands that you can use and so on. So find out more on containers right there. Let me actually just paste this in. And right here. All right. So enough about containers. Let's talk about Kubernetes, because that's the topic for today. And I'm already 20 minutes in and haven't started talking about Kubernetes. So what is Kubernetes? Kubernetes is an open source system for automating deployment, scaling, management, and containerized application. So what does it do? Basically, Kubernetes ensure that pods, a pod, we'll talk about pods a little bit later, but for now you can assume that a pod is equivalent to a container. So it ensures that those pods are always running. It will make scaling your application a lot easier, and it takes care of all the networking between those different pods. So when you start having multiple containers, you have a database, you have your API, you've got your front end, you'll need a way to start networking between those different pods, and Kubernetes will take care of all of that for you, and we'll see that in a few minutes. The first concept that we'll introduce is the concept of a node, not to be confused with Node.js. So a node in Kubernetes will run your workload by placing containers into pods to run on nodes. So a node will be either virtual or physical machine, depending on the cluster. Each node contains the services necessary to run pods managed by the control plane. Typically, you have several nodes in a cluster. In a learning or resource-limited environment, you might have just one. So when I say Kubernetes has a steep learning curve, all the documentation is kind of dry and looks a little bit like this. So this was taken directly from the documentation. So basically what a node is just a virtual machine or a physical machine. It could be a physical one, but typically a virtual one. And it's so you have two types of nodes. No, I don't have the details of the nodes. So you have two types. So you've got master nodes, which are in charge of dispatching all of your containers, all of your pods into multiple worker nodes. Those worker nodes, the only thing that they will do is to make sure that those containers are up and running. It will run on those physical machines, and your master node will be in charge of making sure to dispatch based on the resource allocation on your different machines, and will make sure that everything is working correctly. So it's kind of the how's it called? Chef d'orchestre. Anyways, okay. So orchestrator, I guess. Okay, so this is what a node is. As I mentioned, I am using Minikube. Hopefully, some of you have already installed Minikube, so you're able to use it. You can do, if you have Minikube and kubectl, you can use kubectl get nodes, And that should show you what nodes you have running on your machine. So in my case, I have a single node. It's a limited environment. I have Minikube running. I have version 1.19 of Kubernetes, so you can see the different nodes that you have in your system. If you connect kubectl to your cluster in the cloud, you might have multiple nodes. Then typically you would have 3 masters, 3 workers for redundancy. But right now I only have 1. All right. Out of curiosity, who is following along with Minikube? Who has it installed? So let me know in the chat, just so that I know. Also, at any given time, let me know if you need to, if you need for me to pause or go slower, go faster. Feel free to use the chat. I'm monitoring it. Installed Docker, Minikube, kubectl, following along. I have installed. Perfect. So we've got a few people going along. Let me know if there's anything, if I go too fast or not fast enough. All right, we've got a lot of people following along. That's great. That's great. A lot of people tend to just watch online presentations, but I'm glad that people are, wow, okay. So we've got at least 10 people following along. That's great. Okay, so let's talk about pods. So pods are the smallest deployable unit of computing that you can create and manage in Kubernetes. A pod as in a pod of whales, Docker whales, pod of whales, is a group of one or more containers with shared storage, network resources, and a specification on how to run those containers. So basically so somebody's having an error. The connection to server localhost 8080. I'm not sure what you're trying to run here. So if you want to add more details, I'll try to debug you, or not, we'll just move on. So a pod is one or multiple containers. So you might have multiple containers if they're very tightly connected one to each other. Minikube start is the first thing that you'll need to do. And then you'll be able to use kubectl. Sorry about that. I forgot to mention that. So a pod will have one or multiple containers. An example of a pod with multiple containers could be if you have a MySQL database and you want to have a PHP MyAdmin to manage your MySQL database. So those are so tightly connected one to each other that you can put them inside the same pod. But typically, one pod, one container, and you would use it that way. Okay, so let's talk about a pod. Let's actually, let me just find my code window again. That's the one I'm going to use here. That's the one that I'm going to cheat and look at. So there it is. Perfect. So let's go ahead and create our first pod. So what I did here, I just open up another terminal window. Okay, I just created a lab folder. There's nothing in there for now. And let's just go ahead and open up VS Code in my case. I'm gonna create a new file. We're gonna use a YAML file. So the first one will be called one.yaml. Not very original. And let's go ahead and create our first Kubernetes object. So Kubernetes objects always have the same, they always work the same way. So first of all, you have an API version. Then you have a kind. So you're creating an object. You have to specify what kind of object that you're actually creating. And then we have a metadata. And I can never type that word. I don't know why. It just doesn't work with my brain. Okay, metadata. And then we have a spec. So all a Kubernetes object will have that same definition. So for our pod, let's start with the API version 1. We'll create an object of kind pod. For the metadata, you will have 2 things in here. You'll have a name and labels. Let's talk about labels later, but we'll just give it a name for now. So we'll call it hello. We'll go with a hello world example. And in our spec, we will create an array of containers. So we can have one or multiple containers. In this case, we will have a single container. Let me just make sure that I have that chat window open to see if people are talking. So containers, and you use a little dash to create an item in your array in YAML. Hopefully everybody's somewhat familiar with YAML. It is, YAML is YAML. All right, so our first container will have a name as well. So we'll also call it hello, just for why not. And then we'll use the image node 14. So you need to start or create an image or use an image for your container. So this could be the one that I created earlier, or I can just use node 14 directly. Once that container starts, we will run the command /bin/bash with the argument -c and the argument --. So what this will let us do is to run a command after that with the following arguments. And the arguments here, and I'll copy that in the chat in just a few seconds. So we'll use node-e, so we'll just run a Node.js command. And whoops. The command that we will run will be console log hello world. And we'll do a set timeout. And now I've got to make sure that I've got all my parentheses at the right place. That's always the challenge. Okay, so this console log terminating, and we'll give it a 30-second pause. 30 seconds, parenthesis, semicolon, end of the quote, another quote there. Whew. All right, let me paste that one in because if you're trying to follow here, that's going to be a little bit tricky. There you go. So we've got this running. What else do we need here? I think that's it. So we've got our first pod definition. So this is what a pod will look like. So it will create a single container in there that will use the node 14 image, and it will run this node evaluation and will output hello world and then terminate after 30 seconds. So let's go ahead and use kubectl. And we will use kubectl apply. So apply will take that YAML file and just throw that back into our Kubernetes cluster. -f to say we're going to use a file here, and I'm going to use one.yaml. So this is the file that I want to apply inside my Kubernetes cluster. So I've got my response, pod/hello is created. So if I do kubectl get all, I will see all the objects that I have inside my Kubernetes cluster. And I can see that I have, well, one pod. That's all I have. There's also the service Kubernetes. That's because Kubernetes has an API. So when I'm injecting stuff by using kubectl, it actually uses this API, but you can kind of ignore it for now. So this is what I have. I have my pod hello. One other thing that you can do with kubectl is kubectl logs, and that will look for a pod called hello. And I can see that it said hello world. I can also use it with -f. That should track anytime that there's a change. So if there's another entry that is console logged, so we should see a terminating in just a few seconds. It should be displayed in real time there. Well, it should. Did I type in 30 seconds or 300 seconds? No, okay, there it is. So terminating. So you saw how that that pod started. It ran that eval on Node.js. It did that console log, and then console log terminating after 30 seconds. And that is the end of our node process. Here's something interesting. If you do kubectl get all again, you will see that we still have that pod running. It's ready, running. But it says restarts here. Restarts 2. So it restarted 2 times already. Because it's been running for 83 seconds. So after 30 seconds, that node process stops and the container just stops because there's nothing else to do. So the container stops, and Kubernetes wants to keep those pods alive. So that is one of the things that Kubernetes will try to do. So when it detects that that container stopped, it immediately restarted that container. So it's always being restarted after 30 seconds so that there's always something running. Can I paste in my YAML config file? Yes, I can. Let me just paste it in right here. That's a good idea. Actually, I'll just paste in the full YAML files. Ugh, we're not going to get the spacing right. Let me just share something else here. Hands-on. This is my first time giving this workshop, so there's still a few adjustments, so thank you very much for your patience. Right here I have, there we go. Now I believe that there is value in following along. Nope, that's not the right one. There it is. All right. So that's why I don't want to share all of my GitHub repo right away, but you can probably figure out where everything else is. Kubectl apply -f one.yaml was the command that was ran to start that pod running. Okay, so let's just wait 1 second to see if everybody can run this pod, and let me know by using the yes, or let me know by using the yes to tell me if it worked. If I have enough people that have yes, then I'll just start moving along. We've got a few yeses. I'll wait a few seconds because I don't have a lot of yeses. All right. So let me know if there's anything else that you need from me. So I've shared the GitHub repo that has the one.yaml file. So you can copy from there. You can then use kubectl apply -f one.yaml, and that should apply the YAML file. All right, let's just wait a few seconds here. I'm going for a drink every time I wait. It's going to be a long day. All right, so you apply the flag. You apply the. Okay, so kubectl apply -f one.yaml should be the command to apply and to create that pod. Once you've applied it, kubectl get pods should show you the pods. So kubectl get pods will give you this or something like this. Something like this. Actually, I technically did kubectl get all, but it's the same thing. You can see that after a point when Kubernetes detects that it's always crashing, it will stop and just give you a crash loop back off message. So it started 4 times and then it stopped running. Good point, Juan. There is a way to create them with deployments. I'll get back to that. Don't worry. So we're just starting with the basics right now. So we're looking at a pod, what it is, how it's working. Once you have your pod, you can also use kubectl logs hello -f, and you should see the logs of your pod in real time. All right, so I'll move along. Let me try to show you another example. So we'll create another file here. So just a second file called 2.yaml. And it will have the same structure once again. So API version, kind, metadata, and spec. So wait, keep losing there it is, my cheat sheet. Perfect. There it is. Okay, so let's create a second pod, and that pod will run a web server. So it will run a Nginx. The -f for the logs is just to get them in real time. So it's like a tail. I can't remember what F stands for, but you could just use kubectl logs hello, and it will just output the logs so far. So for our server here, API version v1. So it will start the same way. We will create an object of kind pod. Oops. Here's a quick tip. If you install the extension, the VS Code extension, you'll be able to simply by using pod to create all of a pod. So you've got all the definition here. But let's keep to this. We'll create an object of kind pod. We will add some metadata. I told you I can't spell that word. And we will name it web server. Now for the spec, we will have an array of containers once again. So very similar to what we did before. We'll just give it a name. We'll call it Nginx. And we will use the image Nginx 1.17. All right. I'm using 1.17 just because it's cached on my machine. It doesn't really matter. If you didn't put a version number here, it would just use the latest version, which I believe is 1.19 at this point. Let me find the actual file so that you can paste it in if you want to. There it is. And here it is. Okay, so if you want to just copy it from there, or you can type it in right like it is right there. So I've got my YAML file. I am ready to go back to my terminal. In here, I will use kubectl apply -f again. So exactly the same way. So we're going to apply that new file, and we're going to use 2.yaml in this case. And we should see pod web server created. So that means that if we do kubectl get all, we should now see 2 pods plus our Kubernetes service. And there it is. And that one is running. Doesn't seem like it's restarting, so that's good. So we've got an Nginx server running right now. So what can we do with our web server right now? Well, one command that we can use is kubectl exec -it. So if you've used Docker, you'll probably recognize that command. So basically, it lets you execute a command on that pod, and we'll run that on the pod web server. And -- is the command that we will run inside that container or inside that pod. So we will run /bin/bash. So this will open up a bash session. So we'll be able to kind of log inside of that container. Let me paste this in right here. And let's run it. All right, so I'm now logged into my web server. You can say I'm logged in as a root. If I do something like service nginx status, I can see that my nginx server is up and running. If I do a curl localhost, well, I don't have curl installed in there, but so I've got that web server running. I should be able to now to curl it to see the content of it. But if I exit, there is no way for me to actually be able to reach that web server. So this is where we'll need some networking, and this is where Kubernetes will come in and help us with the networking part. So for now, let's keep that web server right there. Let's keep it running, and let's take a look at what else we have here. Okay, so just looking where I'm at. Perfect. So let's create another object. We'll create a third object, and we'll create a toolbox that will actually have a curl installed so that we can use that to test out our web services. Let's go ahead, create a third file, 3.yaml. And actually, let's change that and rename that to 3.json. Because Kubernetes has an API and it actually uses JSON-based API, you can also use JSON files. So it'll use the JSON directly. If you're using a YAML, behind the scenes, it actually parses it into a JSON file. And because we're all JS developers here, I figured you might be interested in using JSON instead. Now, at first, I thought that JSON would be easier to use just because I'm more familiar with the syntax. But you quickly get lost into all of those quotes and commas, and I think YAML kind of makes sense. Like, it took me a while to get convinced of that, but I guess it kind of does. So we can go ahead and create our object. It'll have the same structure, except that we're going to use JSON in this case. So he says, please no JSON. You can actually do it in YAML if you want, if you're up for a challenge. So we'll create an object called toolbox. And once again, let me just cheat right here. For the spec, we'll have, we'll have an object that will have a containers array. So you can see how it's starting to, it will quickly get messy. So we'll create our first container here. This one will have a name. We'll call it toolbox. It will have an image. For the image, I'll use registry.access.redhat.com. Yep. /ub8. So that's the universal base image from Red Hat. It comes with a few tooling stuff like ping and curl, so that we'll be able to use that. And then we have our command. Our command was an array. It will use /, I'll copy and paste all of that. So /bin/bash -c -- and we will have some arguments. And what I'll do here for my arguments, I'll just use a little bash script. I'll just say while true, do sleep 30, done. All right, do sleep 30, done, perfect. So what this will do is that it'll just create an infinite loop and it will just sleep for 30 seconds every time. So that will just keep a process up and running so that our container won't stop all the time, just like it did before with our first pod, it kept stopping. So this one will just always continuously be working. All right, so where is the actual file? Let's find it right here. We've got 3.toolbox. This is my JSON file, you can use that. And let's go back to our terminal, use kubectl again, kubectl apply -f 3.yaml, and it created our toolbox. So you can see that you can use either YAML or JSON, whatever you're more comfortable with. JSON gets a little bit tricky. So let's do kubectl get pods. We should now see our toolbox. So that's good. Why don't we log inside that toolbox with kubectl exec, just like we did before. Toolbox, registry.redhat.io. Thank you. You're exactly right. That's why I was confused between the .com or .io there. And we'll run a /bin/bash. I'm now inside my toolbox, so I can technically do something like curl web server. Still can't reach that web server. So here's one thing I can do. So I can exit from here. I can kubectl back into my web server, get hostname -i. That'll give me the internal IP address for this web server. And now I can go back into my toolbox, curl 172.17, and there you go. So I can now connect to that web server that was there. Oh, and am I still there? Because I see the image being frozen inside Zoom. So let me just give me a wave if you can still hear me. Frozen as well. Can hear, can hear, but image is frozen. That's weird. Maybe Dan can help me out. We'll see. Okay, perfect. So we've got our Magic Dan helping us right now, trying to get that image frozen. In the meantime, so what I was able to do basically is to log into that. There it is. It's back. So thank you so much. So I was able to log inside that toolbox, and I'm now able to do a curl to that web server. So I can communicate to those web servers through their IP addresses. But now we'll need to create a way to so that we're able to use. There's an internal DNS that we'll be able to use and start naming those services. So I got the IP address by logging inside the web server and using hostname -i. Okay, so we've got someone, there's a small issue here, /bin/bash unable to upgrade connection, container not found. What about kubectl get all? And make sure that you actually have that pod running. So pod/toolbox should be running. Kubectl exec -it toolbox /bin/bash should let you in. And copy. Error image pool. Okay, so that's actually a good point, which I didn't plan on talking about today, but if you do kubectl describe, that is actually a way to get more information. So when you're having issues with one of your containers, you can use that pod/toolbox, and that will give you all the different events and kind of tell you what is going on. I suspect that I might be logged into the Red Hat registry at this point, which might be why I'm successfully able to pull that image, but you're not. In the end, it doesn't really matter if you're not able to run that pod, as we won't be using it anymore. I kind of wanted to show you how you can connect and do that networking internally, but we can still move on with the next step, which is what I'll do at this point. If you want to come back to those pods and try them out, feel free to come back afterwards. But now I want to introduce the concept of deployment. So what is a deployment? Well, pods by themselves are kind of useless. So you saw how, it worked in the end. Perfect. So pods by themselves, it's hard to maintain them. And ultimately the goal is to be able to scale, right? So if you need a way to figure out how you're going to spin up more pods and all of that stuff. So typically you wouldn't use pods directly. So it was a nice intro so that you're able to play with them, see what they're actually doing. But now's the time to introduce a deployment. So deployment provides declarative updates for pods or replica sets. So the description on the Kubernetes distribution is you describe a desired state in the deployment, and the deployment controller changes the actual state to the desired state at the controller rate. You can define deployments to create new replica sets or to remove existing deployments and adopt all of their resources with new deployments. Is that clear? So essentially, what a deployment does is that you kind of describe what you want. What are the pods that you want running and how many of them running that you want and all that stuff. Once that is sent to your Kubernetes cluster, Kubernetes will take care of creating a replica set. And the job of a replica set is making sure that those pods are always up and running. So it'll make sure that you always have the number of pods that you want, and it will create them or destroy them as needed. So why don't we go ahead and go back to our editor here, create a new file. We'll call it 4.yaml. There it is. So we'll use the same syntax. So we'll create a deployment this time, but it is using the same syntax. So API version, I believe it's not using v1 though. So let's just find it right here. Perfect. So it's apps/v1. We'll create an object of kind deployment. Our metadata, we'll give it a name and we'll call it hello. So it's a deployment called hello. And we have our spec. Once again, the bulk of the logic of our object definition will go into the spec. In here, we will say, well, first of all, create some containers using the following template. So this is the template for our containers. So basically, everything that we would put inside of our pod, we will put inside the template. So it will have a metadata, just like we did for our pods. But now we'll start using labels. So the label, instead of giving it a name, I'll give it some labels. And I'll say, well, labels are arbitrary. You can give it whatever you want. So in this case, I'll say, well, this pod will have one job, and his job will be to say hello. So this is the label that I'll use. And now I'm going to add the spec for my pod. So for the spec, we will have a containers array, so just like we did for our pods. So remember, right here is pretty much exactly what we did right here. All right. So we'll have an array of containers. Our first container will have the name hello, and we'll use the image Joe Lord, that's me, / hands-on Kates or Kubernetes / say hello. All right. So let me just find the actual code. I saw that I had a question. I'll get back to that in just a few seconds. I get easily distracted by questions. So I'll just finish my deployment, and then I'll come back to various questions. Not this one. Where am I going? Zoom meeting. There it is. Boom. Okay, so I've got my deployment. Let's go ahead and apply that to our Kubernetes cluster. So kubectl apply -f 4.yaml. And I have an error. Oh, right. I forgot one thing. Let me get back to my VS Code. There it is. Okay, so I specified the template, but I also need to tell my deployment that you will be watching for pods that match the following description. So I'll add a selector, and I'll say, watch for pods that match the following labels. So that is job, say hello. All right. So our deployment will be monitoring the pods that have the label job equals say hello, and those are described right here in our template. So this should now work. Let me go back to my terminal or reapply this file. And there it is. So my deployment is created. Now the interesting part is kubectl get all once again. And you can see that we've got a lot more stuff now. So we've got our deployment right here. So it created our deployment. Our deployment is requiring one pod, so it's available. It also created a replica set. So you can see here we've got our replica set, and the name is hello-66b6 dot dot dot. That is a random number that should have been assigned to you. So it might be different on your machine. And that replica set is in charge of making sure that we have one desired pod, so always have one pod ready. So right now we currently have one, that's good. And we can see that we have a pod hello-66b6 blah blah blah, which is our replica set. And it assigned a new random number to it. All right, so we can all see all the different pods that we have here. Here's another command that you can use, kubectl get pods -l. So give me all the pods with the label matching job equals say hello. And that should give us a single pod right here. All right, so let me just paste that in the chat right here so you can test it out. And we can also similarly use kubectl logs -l, job equals say hello, and we will see the logs from this pod. I can use -f as well, so I'll be seeing them in real time. So every 15 seconds, I should see a new line coming out. So that's the application that I've shown you at the beginning when I was talking about containers. All right, let's take a quick look at the questions. So, all right, so it seems like it worked. Labels are completely arbitrary. Yes, there are some best practices on how to use them. Using app equals something for certain spaces that you can look up best practices for labeling in applications, but it is completely arbitrary, completely up to you to decide what you want to do. Okay, so we've got this pod running. We've got our deployment running. So let's see what we can do with that deployment. kubectl scale is kind of neat. So you can use kubectl scale. That will apply on our deployment /hello, so the name of our deployment. And we can say replicas equals 10. Can pod YAML files be referenced from deployment YAML files? Not that I know of, but I might be completely wrong there. All right, so this is the command to scale up your application. And if I try this, application was scaled. Let's do kubectl get all again. And you can see that we've got a lot more stuff. So we've got all of those containers. They're all container creating at the moment. And now if I run that logs again, attempting to follow 10, so I can do max log requests equals 10. And now I should see all of my logs. So you can see that I'm outputting the name of the host name right here. So JG or SVH and so on. So they're all outputting, and you can see that there's an output from each one of them every 15 seconds. So this is why you will typically use deployments instead of pods, so that you have a lot more control on how those pods are going to run inside of your cluster. I can run kubectl scale deployment /hello -- replicas, and let's bring it back down to 2 replicas. kubectl get all quick. And then you can see that our replica set is trying to terminate all of those. So it'll try to gracefully terminate all of our pods, and it'll just keep 2 of them running. So PXX and 5MZ, and SV should be running. So if I do it again, in just a few seconds, they should be turned off, and we should be back to only 2 replicas at this point. Anytime now. All right, so we can now create deployments, and you can see how deployments map to our pods. And let's go ahead and create a real application this time. Now I have a front end that was created with Vue.js, and everything is already in a container, so it doesn't really matter what it was created with. But basically, I've used Vue.js, and I've created a container with an Nginx server with the static files that came out of the build process. So if you look at my talk containerization for software developers, you will see how I actually created that Docker file. So let's go ahead and create a new file here. We'll call it 5.yaml. And we will use the same type of structure. So first of all, we'll have API version v1. We will, sorry, that's apps/v1. We will create an object of kind deployment. We will have some metadata. Now we're creating a real object, so let's make that a little bit more, real life like. So we'll give it a name. We'll call it front because that's our front end, and we'll give it a label as well. So labels, app, hands-on Kubernetes. Let me just put that right here, just like I have in my cheat sheet right here. Okay. Now on for our spec. So the spec for our deployment, we'll specify right away that we want 2 replicas. So instead of using that scale, we can immediately put in. Can you summarize shortly what a deployment is? Sorry, ignore. So deployment, shortly, I'll still mention it, is just basically the plan or the schedule that you want for your pods. Like it just describes what are the pods that you want and how many you want at any given time. Okay, so right here, we'll have our selector once again for our deployment. So it will look for pods that have match labels. So looking for pods that will have the following label, we'll say section front. So any pods that have that label, so any pods that are for our front end will be matched here. And now here's the template for the pods that we want to create. So let's put in some metadata. We will, not a name, but we'll have some labels. Those pods will also be part of the application hands-on Kubernetes. So you can apply that label to as many objects that you want, but they will also have section front. So this is important so that this label matches those pods. Now that I'm done with my metadata, I'll go on with my spec. And we will have containers. Our first container will have name front. And we'll use the image Joel Lord / hands-on. Is there a dash there? Hands-on Kubernetes -front. All right, so this is the name of the image. That image is already pushed on Docker Hub, so you should be able to pull it. And now I can do ports. And this image is running container port 8080. All right, so this is my deployment. Let me paste that in, or the link for it, in just a few seconds. Right here. And back to Zoom. I keep losing my Zoom window. There it is. Okay. So if we go back to our terminal, kubectl apply -f once again, and we'll apply 5.yaml. It created our front deployment. So kubectl get all, and we can see that we've got our front. So we've got 2 containers running with that front end. All right, so we can now create deployments. I am ready. So there's a problem with our services that there's no way to reach them yet. So we still can't reach our web server. We still can't reach our front end. So this is what we're going to do. We're going to slowly introduce services. Before I jump to services, is there any questions? I'll let you 1 second to type it in. Seems like we're good so far. Also, as I mentioned, it's my first time giving this workshop, especially in the virtual world. It's a little bit different to give workshops. So any feedback is always appreciated. Feel free to send any positive feedback on Twitter so that my bosses also see it. So Joel__Lord, or send me a DM for constructive feedback so I can make this a little bit better for next time. Or if you have negative feedback, just keep it to yourself. Okay, so no questions so far. So let's move on to services, which is the third really core concept that I wanted to introduce today. Once we're done with those, everything else is kind of just extras. So let's talk about services. So a service is a abstract way to expose an application running on a set of pods as a network service. With Kubernetes, you don't need to modify your application to use an unfamiliar service discovery mechanism. Kubernetes gives pods their own IP addresses and a single DNS name for a set of pods, and you can load balance across them. Okay, so remember when I went into I logged inside that web server, I did hostname -i, that gave me the IP address of that specific container or that specific pod. Now I was able to go inside my toolbox pod, and from there I was able to curl that IP address. That's because there's a whole networking going on inside of that inside of our Kubernetes cluster. So they have their own IP addresses. Each pod has their own IP address, but there was no way for me to just directly address web server. So in order to do that, we will need to have a DNS, and there's one part of Kubernetes already, but we need to inject our pods inside our service. Now the service will take a deployment, so we'll say, well, or take a set of pods, and we'll say, well, all of the pods matching a specific label or however we want to describe them, then send all of the traffic to all of those pods. So if we had, in this case, I have 2 front ends running, so 2 Nginx servers with my front end running. So I'll create a service so that it sends all the traffic to, what was it called, front, and it will do the load balancing between those multiple containers. So really cool, you can do, it takes care of all the load balancing for you, it takes care of internal DNS and all that stuff. So let's go ahead and jump into that. Just before that, I see that I have a question. Can we have a shared node modules for all pods? The quick answer is no. There is a way to create shared spaces, but really, the way that your container works, you should have your node modules inside each one of your containers. Once you've downloaded all of it, it stays there and can be reused. It can also be cached, so it's much faster to reuse. But the node modules goes inside your containers, which then goes inside of your pod. That is the typical way to do it. I don't see a real advantage of using a shared node modules, especially that some of those node modules will be compiled for a specific operating system, which shouldn't be an issue because all of those pods will be running Linux, but it's a better practice to put all of your node modules inside that container. So hopefully that answered that question. Okay, let's move on with our services now. So for our service, I'll go back to my terminal here, and we'll create a new file, 6.yaml. I don't feel very original with my file names today. So 6.yaml, and in here we will create an object of kind service. So API version again, this is version v1, kind service, metadata, data. We will create, we'll name it front. So nothing prevents us of reusing the same names as long as it's on different kind of objects. So I can only have one deployment called front, but I can have a deployment called front and a service called front. I like to keep the same names for things that are related together, so it makes it easier to find them afterwards. Also give it some labels. So this is also part of the same application. So hands-on Kates. And then we have the spec for our service. So in here, I'll use a selector. So similar to what we did for our deployment. And I'll say use any label matching front section equals front, right? So those are all of our pods that have this specific label. And then I'll map some ports. So I'll say any traffic that comes to service, we will expose the port. It's an array, so one port 8080, too many 80s there, and on protocol TCP. So basically I'm telling this service, open up this port. So you can accept now traffic coming to port 8080 through PCP protocol to go to all of those containers. And if you remember correctly, I'll just jump here very quickly. We did expose our container port right here. All right, so that's port 8080 right here. It maps to this port 8080 here. Let's go ahead and deploy this. Kubectl apply -f6. So our service is now created. kubectl get all should show our service. So we got our service Kubernetes, which is the Kubernetes API, but we also have this new service here. So what can we do now that we have this service? What I can do is that I can actually jump into my toolbox again. So remember what I did earlier. I was able to do a curl. Not everybody managed to get the toolbox up and running, so I'll just demo it for now. And we can do curl front port 8080, and there you have it. So we've got our server, Nginx server, replying us. It says, JavaScript is not enabled, which kind of makes sense with a curl. But basically you have, the link for 6.yaml, you're right, sorry. So basically you now have a service, and you see that I can now use the name front because that was injected into our DNS, our DNS that runs inside of our Kubernetes cluster. So I'm now able to contact some of those services. If I were to create a service for my web server pod, I'd be able to use the same thing, curl web server, and I would be able to reach it directly with the host name now. What is also really cool is that it will do load balancing. We'll see that in a few seconds because that application will also show us what host it's running on. All right. There's one final topic that I wanted to introduce today, which is called an ingress, which is how to expose that service to the outside world, which is where it starts to get a lot more fun. So yeah, I still have 20 minutes to do that. Should be plenty of time. Is there any questions on services at this point? Having the same name as the section is intentional. That is not intentional. That is just me being lazy with my naming. I should really work on that a little bit better, so that I have different names, so I don't reuse the same thing all the time. But no, there's no connection between the labels and the name that I gave it. Is just out of pure laziness. Can you repeat what is a service definition? I cannot repeat it because really I don't remember what it was, but I can put it on the screen. So basically, a service is a way to create a DNS entry for a set of pods, basically. So a service is solely for internal use. You are correct. It is only for the internal DNS. So if you have multiple microservices speaking to each other or talking to each other, then you'll use those services so that you can expose those multiple microservices to each other, or through or a good example would be creating that for your messaging queue, and then all of them will be able to address the messaging queue through a DNS name instead of having to find that IP address through some sort of discovery mechanism. How do you create a load balancer across those pods? Good question. Magic. That's how you do it. So when you create a service, it automatically creates that load balancing across all of the different pods for that are exposed through that service. So everything is taken care of for you automatically by using a service. So that's one of the really, really cool things about Kubernetes. I should have put more emphasis on that. It really makes your life easier, so you don't have to start doing that load balancing. You can specify as part of your service how you want that load balancing done. I believe there are a few ways. I am familiar with the round robin, which is what is used by default. So basically, it will send a request to each one of the pods one after the other. But I believe there are ways to do it with the current on how busy they are and so on. Is there a way to connect a specific pod in a service? Well, you would do that through the selector, and in this case, I'm connecting a set of through some labels. You could have a single pod and just give it a label, and then you'd be able to use that selector for that specific pod as well. I mean, send an HTTP request. So this is what I did exactly, right? So in here, I logged inside my toolbox. And from my toolbox, I was able to send an HTTP request to not to a specific pod. So if I was able to send a request to my service, which then sent it to a specific pod, you can also send them to a specific pod. I believe you would need to find the IP address of it, and then you'd be able to send it to that specific pod as well. But really what you want to do here is to start using deployments and services so that you don't have to find specific pods. That's the whole point. How do they say that when you're using Kubernetes, it's not about pets, it's more about cattle. So you don't care about the unique individuals. You don't care about those pods anymore, but you care about the whole group of pods that you have. So in this case, what's really cool about that is that if one of those pods crashes for some reason, if someone manages to get into that pod and to do something to it and it crashes the pod, well, Kubernetes will automatically take care of restarting that pod. And so now it will have a random name, it will have a different IP address, everything will be different, but you'll still have a pod up and running. So you have to make sure that they are stateless and that they can be restarted easily. So that's really the key to when you're starting to use Kubernetes. But yeah, and at that point, you would, even if it's just a single pod, you will still create a deployment for one single pod, and you would create a service for that pod so that it would always be exposed through that service, which makes it easier for the discovery of that single pod. So that's kind of how you would do it, even if you had one specific pod that you want to address. So you could do those HTTP requests to those pods. Now, if you want to do an external request from the outside world, from the public internet into that cluster, well, this is exactly what we're going to look at right now. To do so, you will need an ingress. So that was a nice way to get into that. So an ingress is an API object that manages external access to the services in a cluster, typically through HTTP. Ingress may provide load balancing, SSL termination, and name-based virtual hosting. So basically, what you're doing here is that we will establish a set of rules. So those rules could be based on the domain name. So you could do some routing based on any incoming request to www.mydomain.com will be redirected to my front service, and any request to api.mydomain.com will be sent to my API service. So you can redirect based on a bunch of different rules. You can also use the routing. So this is what I'll be using here. Actually, I won't have the time to show you how to use it with the API, but I'll kind of show it very quickly at the end. But I'll be able to route my traffic to / into my front service and to /API / something else to my API. So you can create all of those rules to expose the different services that you have running in your system. So I'll just go ahead. I'll pick up the pace a little bit. So let's go into right here. I'll find the 7.yaml. And there it is. Where's my Zoom? Zoom is here. There you go. And I will also just paste it in to my editor right here. So 7.yaml. All right, so API version networking.kubernetes.io. We will create an object of kind ingress, which will expose everything to our outside world. I'll give it a name, so it's my main ingress. Rewrite target will be used in the more advanced ingresses, but I won't have the time really to cover that. I'll quickly show it afterwards. And then you specify all the rules that you have for your ingress. So in this case, I'll do some rules based on the HTTP protocol. I will make the rules based on the path for my incoming request. So any request incoming to / will be sent to this backend, so to the front end. So that terminology here is a little bit confusing. So a backend is something or some sort of service inside of our Kubernetes cluster. So in this case, I'm using service front and to the port 8080. So any incoming request to my Kubernetes cluster on port 80 will be redirected to the front service on port 8080 right here. So that is all done internally through some port mapping. So let's go ahead and apply this. kubectl apply -f7. And we've got our ingress. Fun thing here, kubectl get all. You won't see the ingresses in get all. So get all will show your pod services, deployments, and replica sets. If you want to see your ingresses, get ingresses. You can see them right here. All right, so we've got our main service here. So what that means is that I can now, in theory, from here, let's just use minikube IP. All right, so that gives me the internal IP address for my minikube virtual machine running on my laptop. So now I can do curl localhost, not localhost. I can curl that IP address, and I can now contact my front end. If I open up a window right here, paste it in that IP address, I can now see my application. It is exposed to the real world. And here I can see the name of the pod that answered that request. So the front end, HDJFR. Fun fact, if I refresh, there we go. So now this request was answered by ZDH7N. And in theory, if I refresh again, it should always be a different one. So there's that load balancing for you. So all that load balancing is done automatically through our service. So you can see here that it's a different service answering every time. What I wanted to do as well was to create that API. Right now, I won't have the time to deploy all of that, but I'll still quickly go through that code with you. So just to give you an idea, and if you want to do it on your own, you'll be able to do it afterwards. So we did 7, 8 is our deployment for our API right here. So I'll share the GitHub repo at the end. So this is the deployment, very, very similar to the deployment. So you'll see that those deployments are always pretty much the same thing. But the main difference here is that I'm using a different image, as well as a different port, because my API is built on Node.js. You can also add more than one object inside a single file. So I can separate those by the 3 dashes here. I can also create my service for my API. So very, very similar to the other one again, but you can see that this service is on port 3000. I have my 9.yaml here. And that is our advanced ingress. So let's take a look at our ingress here. I've added an extra rule on the path. And I can see that any incoming request to /API with an optional slash here and everything afterwards will be redirected to the service API. So it will be redirected to my API here. And I've kept the other front service. So any incoming request to /, and there's a little bit of regular expression voodoo here. So just an empty object, just so that I can map with the object number 1 here. And that's my object number 1, and any incoming request. And the last rule is, the rules are always followed in order. So if it finds /API /something, it will be picked up by this one, and /anything else will be picked up by my front end. And now my rewrite target that I had earlier, I just redirect everything to or I rewrite my target to be / the second item in my regular expression. So what that means is that it will take an incoming request to /API /hello, redirect that to my service, to the API service, but remove that /API and the optional /here part. So it will just remove that, and it will just keep item number 2, which is anything else after the first part of the route. So a little bit of regular expression magic here. That also works for a second one. So if I had an internal router, so a Vue.js or a React application with an internal with a router inside of the application, I would be able to use my front end / whatever dashboard, and then that would be picked up by that second route here. So now I use that advanced ingress. I can add that afterwards. And what do I have here? I have another deployment for, yes. And then you can also add your environment variables to your front end. So this is what I'm doing here. I'm adding an environment variable to specify the base path for my API inside of my front end. So I'll just go ahead and apply those files, -f. They were in my rehearsal, 9 and 10. And everything should now be up and running. I now have my application running. You can see how I'm getting the response from a different server. So NW wasn't there before. That's because I added those new environment variables. So Kubernetes immediately took care of starting 2 new pods and trying to gracefully terminate the other pods that were existing before. And now I can contact the API and I can see that my request is done to hello, and it was answered by this specific pod right here, by API / yada yada. So kubectl get all. You can see I now have a bunch of different things. I've got my API pod running. I've got 2 services. I've got 2 more deployments, and my new services are all there. My replica sets, and my ingress was changed to accommodate all of that. If you are following this and looking at the recording, and just for fun, you will find in the README file, there's another API that you can add. So there's a little challenge there for you. So you can take a look at the README on my GitHub repo. You'll see there's another service that you can add for an API that just crashes. So those buttons here, contact crashing API, you'll be able to deploy that API, change your ingress so that it picks up that new route, and change the environment variables so that it actually can redirect traffic to there. So here's that's a little challenge for you. Let me see if there's any questions here. I can see a few. Unable to recognize for kind ingress in networking. Oh, right, I forgot that in Minikube you will need to do Minikube add-ons enable ingress. I believe is the way to do it. Let me just copy this. Yeah, it's already enabled for me, so that's good. Yes, I forgot that. Make sure that you enable the ingress add-on. So Minikube is a stripped-down version of Kubernetes so that it can run on your local machine, but it doesn't have all of the features of Kubernetes. So you need to install some of the add-ons when you want to go with more advanced topics, I'd say. So ingresses is one of those where you need to actually enable the add-on first. You can also try V1 Beta 1. It was in beta until about a month ago, so it was just released a new version. So the examples, I've updated them yesterday so that they actually use the new version. But yes, you could still be able to use version 1 Beta 1. Gives another error. That makes sense. Minikube add-ons enabled. Yep. Okay. Thanks. Let me know if that works. Out of curiosity. That's all I had. That was a lot of content. That was a lot of stuff that we went through. Fortunately, I thought I would go through the whole example, but still I went through the important parts. Where is my slide deck again? In my terminal. There it is. So deploying the API. So that's all I had for today. Hopefully you've got a little bit of a better idea on what is Kubernetes and how you can start using it. Really, my goal is to give you enough content so that you're able to start Googling stuff. Just looking at the documentation can be a little bit tricky. Like I said, it's a little bit drier than I wish it would be. So it's hard for someone new to the Kubernetes sphere to come into, but hopefully you have enough information here to get started. I'll stick around for another 10 minutes. If you have any questions, I will have to leave the room soon, though, just so that people can come in for the next workshop. And you can go to the next one if you want to, or if you have another one. More information available on easyurl2/hands-on-Kubernetes. There's a few links there. You can find my slide deck, so you'll be able to try out some of the things. And feel free to reach out on Twitter. Twitter is always the best way to get in touch with me. More than happy to answer any questions you might have over there. And like I said, I'll stick around for a few minutes. Apart from that, thank you very much for being here. Hope you enjoyed the conference. NodeConf is great. Unfortunately, it would have been nice to meet in person, but I'm glad this actually worked out better than I thought it would. So thank you very much for attending, and hopefully see you next year.